welcome to Ontology Engineering and Intelligence Analysis. Today we'll be discussing foundations for the intersection of this field, which will occupy us throughout this course. As you'll see, I'll begin in this first lecture with some discussions of intelligence successes and failures, and doing so illustrating what intelligence is, and the scope of that will be, at least for the purposes of this course. And that will be preliminary before jumping into more refined characterizations of intelligence and distinguishing it from nearby phenomena that you might be familiar with in natural language. Also, in doing so, in the second portion of this lecture, I'll be discussing some of the tactics that we employ as ontology engineers when we try to become precise about the meanings of the words we use. So, starting with the first, successes and failures. The gentleman you see here on the image, that stern-looking visage, that's Hannibal of Barca. He was the head general, the lead general of the Carthaginian Empire as it went to war with the Romans way back in 216 BCE. This was the second Punic War, they called it. The first one involved Hannibal's father, who was decisively defeated by the Romans. And Hannibal, as you can probably tell by his face, was out for revenge. Now, Hannibal was a very successful general, particularly against the Romans. He knew how they fought, he understood their tactics and their motivations, and he was, because of that, a significant threat to them. He brought an army famously through the Alps, which protects the Italian peninsula where the Romans' homeland was. It protects them from the rest of Europe. Now, he took a large army of Carthaginians, elephants included, over the Alps, surprised the Romans in their own territory, and pushed them back again and again after battle after battle. Now, at some point, the Romans decided, we're just going to throw everything we have at them. They marshaled a troop of 70,000 people to push Hannibal out of the peninsula. Now, several of the troops that were marshaled by the Romans were Celtic warriors from up north, outside the scope of the Italian peninsula, who had been subjugated by the Romans. Now, they were not exactly happy with the Romans. They were a little happier with Hannibal, though, and happier with the prospects of not being under the foot of the Romans. And so many of these Celtic warriors were spies for Hannibal. They would pass information to him about what the Romans were planning to do, what they had done, their tactics, their resources, etc. So in the face of these 70,000 troops, armed to the teeth and ready to go to war, Hannibal had quite a bit of intelligence from a spy network on his side, as well as the military genius that he exhibited. Now, in this battle, by many considered to be the most decisive victory of any recorded battle in history, Hannibal had a stratagem based on what he'd observed from the Romans in the past. So he'd seen that the Romans tend to push through the center of forces. They block up in lines, just as you see here in Roman infantry. They line up together, and then what they do is they press forward, and what they try to do is separate the insides. They try to segment the inside of the opposing army so they can split them off from one another and attack them at two places. Now, Hannibal observed this. He'd seen the Romans be successful even against his own troops in this tactic. So what he did is he placed his weakest troops in the center to bait them into doing that tactic, and he put his strongest troops on the exterior, on the outside of the flanks of his forces. Now, he did this because he knew, again, that the Romans were going to press inwards, and he wanted the center to buckle. Not too much, but just enough to create an encirclement. So as the Romans pressed inwards and Hannibal's weaker troops pulled back, the elite troops circled around the rest of the Roman army. Eventually, they completed a full circle. They fully encircled the army, and 60,000 Roman soldiers were killed during the battle, which was approximately 20% of the adult male Roman population at the time. Now, for what it's worth, Rome did ultimately win the war. Now, that's a topic for another conversation, but impressive as it is, again, this was quite a coup, destroying almost 60,000 Roman soldiers by complete encirclement of their army based on military tactics, stratagem, and a bit of a spy network that Hannibal used. I was just illustrating successes and failures of intelligence, but here's another. In 1942, during World War II, just after the U.S. had entered the war, that is to say, right after Pearl Harbor, Douglas MacArthur was the commander of the U.S. forces in the Far East, and he was stationed in the Philippines. He was, however, forced to retreat during an invasion into the Philippines. Now, this was the culmination of a long-term strategic plan by the Japanese military that had resulted in spies infiltrating both U.S. and Philippine organizations on the island. It is reported, for example, that a gardener for the Philippine governor was actually a high-ranking Japanese military officer. They had permeated throughout the Philippines so that they could gain intelligence about what U.S. officers were doing there, what they were planning, and how they would be defending the base if they were attacked. Now, to say this was a battle would be an exaggeration, because as soon as it became clear how far the Japanese had penetrated U.S. and Philippine organizations, all MacArthur could do was flee the island. The battle was over rather quickly. These examples illustrate both intelligence analysis failures and successes. The failure of Roman consuls to acquire and leverage intelligence while battling Hannibal was compounded by Hannibal's proclivity for leveraging intelligence. And the intelligence failures of the U.S. and the Philippine military forces were magnified by the long-term intelligence strategies deployed by the Japanese military. Here's another. In 2001, 4 U.S. commercial airplanes were hijacked by members of Al-Qaeda intended to crash them into the Twin Towers, the Pentagon, and Washington, D.C. All were successful with the exception of the plane crash in D.C. The Twin Towers famously collapsed during the attacks, and nearly 3,000 people were killed. The resulting investigations revealed that U.S. intelligence agencies knew Al-Qaeda was mobilizing, but information was not shared very freely across agencies. And at the time, the NSA, the National Security Agency, considered itself just an intelligence curator. If some other agency asked whether Al-Qaeda was mobilizing, they'd confirm, but few knew to ask. These attacks were magnified by failures of intelligence sharing across the U.S. government agencies. Now, since that time, the U.S. government established the Patriot Act to ensure such failures did not happen again, which expanded surveillance capabilities of law enforcement and eased information flow across agencies. Still, intelligence permeates these examples, as I'm sure you can see. Leveraging intelligence led to more informed decision-making during crisis, but on the other hand, when intelligence was either absent or present but ignored, or present but siloed, the irrelevant decision-making resulted in devastating losses. Intelligence, as you can see, is quite important. But with that in mind, it would be remiss if we didn't discuss exactly, at least more precisely, what intelligence is. What is this thing that's so valuable? Well, first thing to note is it's spoken of in many ways. Entities can be considered intelligent, like Einstein or Aristotle, or exhibit intelligence, like performing well on an exam or reading a defense, or activities can be considered intelligent, just like a chess strategy or Hannibal's encirclement strategy. These are all natural language uses of intelligence, and while they touch on what we're interested in for this course with respect to intelligence analysis, they're not exactly what we have in mind. Now, even putting aside these uses of intelligent and intelligence, the sense of intelligence within our scope itself is spoken of in many ways. Traditionally, such intelligence has been viewed roughly as something like a strategic process to guide decision-making and avoid surprises. Now, there's a lot right about that, but also it doesn't really capture the full picture of intelligence that we need to understand in this course. There's a need for more precision. Now, some precision has been offered from authors over the years. So as you can see here, Herman in 96 characterized intelligence as form or power, not unlike military power or economic power. Warner in 2002 described it as information that allows policymakers or operational commanders to make more effective decisions. And then Lenthal in 2019 described it as either a process through which intelligence is requested by superiors, then collected, analyzed, and fed to the consumer, or a product distributed through multi-level secure electronic databases or institutions such as intelligence services. Now, these get various aspects of what intelligence is correct. They each have their problems. The first here is, as I'm sure occurred to you, underspecified. What exactly is it that differentiates intelligence from other sorts of powers if intelligence is a form of power, as Herman suggests? On the other hand, when looking at Werner's characterization, we see it doesn't really distinguish information from intelligence. It just seems like any sort of information can fall within the scope of this characterization. On the other hand, it seems too narrowly focused on policymakers and operational commanders. Intelligence could be useful for other individuals. This last definition or characterization from Lenthal has its problems as well. It seems plausible that one can, for instance, have intelligence that's not requested by superiors or distributed in databases, although that would be ruled out by this characterization. On the other hand, I'll add, it doesn't seem plausible that institutions are really understood to be intelligence rather than organizations that gather intelligence. So again, while these are better than that traditional characterization of intelligence, they each have their flaws. What we're aiming towards is a precise definition of intelligence that is narrow enough to exclude the many natural language uses, but broad enough to serve as a common starting point for more specific definitions. For example, military intelligence or criminal intelligence. Those would be species of the type of intelligence that we're interested in. While, like intelligent, as is commonly used in natural language to describe various individuals, for instance, is something outside the scope of our characterization here. That said, we should, of course, be clear about what exactly we're looking for. For any definition, there's going to be a term that's defined, call it T, and the expression E that defines that term. A definition, then, is a pair of T and E. And for any definition in any domain, T is going to be true of that domain just in case E is true of that domain. A good example of a definition here is what you see before you, triangle. It's defined as a polygon with 3 edges and 3 vertices. And now, when you're thinking about evaluating such a definition, there are two heuristics you should keep in mind. In the first step, with which you assume T is true of a domain, and then you attempt to find a scenario in which E is not. And then the other direction, you assume E is true of a domain, and you attempt to find a scenario in which T is not. We can try this out here to evaluate the definition. So, first we'll assume T is true. Triangle. We'll assume of some domain that I say have a triangle. I see a triangle. I'm holding a triangle, something like that. It's true. This thing is a triangle. Now, to evaluate to see whether the E portion of this definition is accurate, what we'll do is we'll try to find a scenario in which I am holding or seeing or viewing or whatnot, having a triangle that is not a polygon with 3 edges and 3 vertices. Now, I suspect you're going to have a hard time even imagining a scenario in which you have a triangle and it, for whatever reason, is not a polygon, or doesn't have 3 edges, or doesn't have 3 vertices. That's to be expected. As I said, this is a good definition. Now, that's only one part. That's what we call the left to right direction of evaluation. We have to do the other as well. So we have to go from right to left. And so what we do in this case is we imagine we have a polygon with 3 edges and 3 vertices. And it is true that we have this. That's what we're imagining. Then we try to see if there's any way for that thing to not be a triangle. Now again, I think you're going to have a hard time because a polygon with 3 edges and 3 vertices is a triangle. Now if you're unable to imagine a scenario in which one side of that equation is true and the other side is not, it's likely that you have a good definition on your hand. Now let me show you then what a bad definition looks like, just so you have that contrast. A human being. This is a famous definition attributed to Plato. A human being is a featherless biped. Let's try this out. Okay, let's assume there's a human being. Is it the case that this human being is a featherless biped? Probably. What sort of scenario would you have in mind if you had a human being with that was not a featherless biped? It'd either not be a biped or it'd have a lot of feathers on it or something. Seems a little difficult. It seems stretching the what we mean by human being. So maybe the first, left to right, is not too bad. Now, more interesting though is the right to left version. So it seems rather easy to come up with counterexamples. So if you assume you see have a featherless biped, it's not necessarily the case that you have a human being, and it's easy to come up with scenarios in which you don't. A chimpanzee, for instance. That is featherless, biped, not a human being. Perhaps more entertaining, though, Diogenes the Cynic, once he encountered this definition, famously plucked a chicken and proclaimed, "Behold a man." Now, let's try this, what I consider to be a better definition of intelligence, better than any of those that we've encountered so far. And this is from the joint publication 2.0, published in 2013. Now, we will encounter these publications much later in the course, but for now, I just want to highlight their characterization of intelligence here. The product resulting from the collection, processing, integration, evaluation, analysis, and interpretation of available information concerning foreign nations, hostile or potentially hostile forces or elements, or areas of actual or potential operations, as well as the activities that result in the product and the organization engaged in such activities. Now, that's a mouthful. A lot goes into that, but that's kind of to be expected. Intelligence, in the sense that we're interested, is quite complicated. There are a lot of things I like about this definition. I'll highlight some of them for you. So I like that it's involving this collection, processing, integration, evaluation, analysis, and interpretation aspect, because this maps up to what we will encounter again and again throughout this course, as known as the intelligence cycle. As you see, there's a collection component to intelligence gathering. There are processing and integration components. There's evaluation, analysis, and interpretation, the results of which many consider to be intelligence. And again, this is part of the intelligence cycle that we're going to encounter again and again throughout the course. So I find it high quality, or this aspect is included in his characterization of intelligence. Implicit, I'll point out too, in this, by discussing like potentially hostile, potential operations, there has to be some motive in the background, and that is also linked up to the intelligence cycle in terms of planning and direction. It's critical to the success of any intelligence program, but kind of lays down the foundations on which like the collection, processing, etc. is conducted. Now these reasons, though, for gathering intelligence are importantly distinct from the intelligence itself. And that is, again, I think it's important here, and this is another reason why I like this definition, that while crucial to intelligence as a product, nevertheless makes reference to or implies that there was planning and direction which this intelligence gathering, etc., or collecting, processing, etc., is dependent. Nevertheless, there are some issues with this definition, which I'll highlight here, because again, we're trying to be precise about what we mean. So this definition includes within scope of intelligence activities that result in the product that it was in the first clause describing as intelligence. But this can't be true, right? Intelligence is not the same as intelligence gathering activities. It's also quite a bit too broad, right? Does it mean any activity that results in the product? So like an agent getting proper sleep, that counts as intelligence all of a sudden? That can't be correct. Now, to be fair, I don't think folks using the joint publication in this definition would be confused about this sort of case. I think they'd understand, like they're humans, they speak the language. This document is used to help them understand but coordinate their joint operations across one another, and these are sort of boundary cases that I'm pointing to. They're not going to be that concerned with them, and well, they shouldn't. But this leads into the ontology engineering side of this class. So it's not just intelligence analysis. Ontology engineering motivates the precision and the definitions that we're looking for, because when we're thinking about creating ontologies that represent, phenomena in the world, we're actually thinking about representing that for machines. So not just for humans who are using joint intelligence doctrine or whatnot, or publications of this sort, but also definitions that could be machine readable or machine understandable. And when you're trying to construct something for a machine, you have to be very precise, because machines are stupid. They do exactly what you tell them, and no more, no less. These boundary cases that I'm pointing to, agent getting proper sleep shouldn't count as intelligence. I know that. You know that. Agents in the field know that. Computers don't know that until you tell it. You have to tell it. In addition, other sorts of boundary issues that might cause problems. Within scope here, the organizations engaged in such activities seem to be counted as intelligence, but obviously the CIA itself is not intelligence, it gathers intelligence. Similarly, there's a granularity issue. Does it mean all organizations, all parts of the organizations that are engaged in such activities? The CIA's HR department is part of the CIA as an organization, but it doesn't gather intelligence. Should it count as intelligence according to this definition? Again, this should sound silly. It's a lack of precision in the definition that makes it so. Setting all of that aside, this is clearly too specific anyway if we're looking for a general characterization of intelligence, because this is obviously specific to military intelligence, and there are different types of intelligence. For example, like Police officers gather intelligence on domestic criminal activity. Companies gather intelligence prior to mergers. Intelligence abounds, right? So if we're looking for this to be a broad notion of intelligence that can sit on top or like encompass the species or specializations that I pointed to earlier, this is not going to be it. This is too specific to the military context. I will be a bit vexed in coming up with a characterization of intelligence that cuts across all of these, but we will do so. We'll do so by exploring not just definitions of the sort we've seen, see what's good and what's bad about them, but also by expanding our scope and keeping in mind not just users like the military or corporations, but also other aspects of of intelligence like its targets, criminals and corporations, nations, militaries, nonprofits. You very well could be the target of intelligence. I don't know if you see Catfish. I don't know if you watch Crazy Ex-Girlfriend. There's a lot of intelligence analysis adjacent phenomena going on in each of these shows, and depending on who you are, you might be within scope. Similarly, in characterizing intelligence and intelligence adjacent phenomena will also include within scope numerous sources like open source intelligence, or intelligence that comes from humans, or from imagery or signals, or measurements, or the consequences or calculations based on measurements, as well as geographic location information. These are topics that we will encounter as we proceed through the course when we get clearer and clearer about the domain we will be defining. So far, we've outlined foundations in this lecture on which to begin our study of the intersection of ontology, engineering, and intelligence analysis. And we've witnessed intelligence successes and failures, better and worse definitions of intelligence, and refined the shape of our target definition while gesturing at areas we need to explore going forward. Now, we will expand our toolkit during the next lecture, which will help emphasize more of the ontology engineering aspect of this course as we bring intelligence analysis and ontology engineering closer and closer to focus on the intersection between the two.